Hello everyone, welcome to today's webinar. My name is Barry de Graaf and I am Channel Evangelist at Synacor. This is the second webinar in a series about email security. You can find the recording and the slide deck of our first webinar on the Zimbra blog and the Zimbra YouTube channel. In these webinars, we will provide practical how-to information and best practices to help you maximize Zimbra email security. Today's webinar is about DMARC. Upcoming webinars will cover things like MTA-SDS, DANE, DNSSEC, and more to ensure maximum email integrity and confidentiality. During this webinar, you can ask questions via the Q&A panel, and I'll try and answer them on the fly. Some questions we may also discuss live during the webinar. Today's webinar is recorded and will be published on our blog and YouTube channel, where you can find it for future reference. This webinar is a collaboration between Zimbra and Randy Leiker from Skyway Networks. Randy is an expert in email security, and he will provide you with all the best practices and insights you will need to get started on maximizing your security. So without further ado, I would like to give it to Randy.
Well, thank you everyone for joining us today for this second episode in the Zimbra webinar series that is all about email security. Today we will be focusing on the topic of DMARC. For those of you who are joining us on this webinar series for the first time, as a brief introduction, I am the President and CEO of Skyway Networks. Skyway Networks is an email service provider specializing in Zimbra hosting and consulting. We also do a variety of cloud hosting services, including software development. I've been in the IT industry for 26 years, and at that time, 23 of those years was Skyway. And I've personally been working with Zimbra servers dating back to Zimbra version 5.0. As an overview of today's topics, we will be covering the DMARC standard, including all aspects that you need to know to get started and get also the most benefit from it. DMARC is a powerful tool in your toolkit for email security and includes a range of capabilities intended to provide authentication, reporting, and conformance with your organization's security policy. Even if you've already deployed DMARC, there's something here for everyone, as I'm going to discuss a number of real-world use cases and best practices, along with common deployment pitfalls to avoid that are not always obvious, even for those that have been already using DMARC for some period of time. At the end, I will pause and take any questions and try my best to answer those for you. This webinar is being recorded, as Barry mentioned, and will be posted later on the Zimbra YouTube channel at the URL you see on the screen. So this is the second episode in this webinar series about using modern email authentication and encryption to protect your users from a diverse range of threats. Some of these threats include phishing, eavesdropping, information leakage, man-in-the-middle attacks, and security downgrade attacks. In the previous episode, SPF and DKIM were discussed in depth, and this episode will build upon those concepts. But in case you missed it or want a refresher, the SPF and DKIM episode is available again at that same Zimbra YouTube channel. In each webinar episode, I will refer to outside documentation and tools where relevant, but the goal is to get you information that you can immediately use to get started with these security standards within a short time frame, without needing to spend days or weeks reading documentation. So with that introduction out of the way, let's dive right into the topic of DMARC. So in the early, I'm sorry, my notes are wrong here. There we go. In the early 2000s, SPF and DKIM became those standards and provided an evolutionary leap forward for authenticating that email senders were who they claimed to be. But these two standards alone still left a few security gaps that could still be exploited. So starting around 2006, PayPal, Yahoo, and AOL had a serious problem on their hands. Their domain names were some of the most abused on the internet, frequently used in email spoofing and phishing attacks. While these companies had deployed SPF and DKIM records, the bad guys realized that the SPF and DKIM standards alone did not specify a mandatory action that a recipient must take when an SPF or DKIM validation failed, but rather left it up to each recipient's mail server to decide. So furthermore, SPF and DKIM provided no guidance on what should happen when the from address that a recipient sees does not match the actual from address from which an email was sent. To combat this problem, these three companies came up with a new proposed standard called DMARC, which is short for Domain-Based Messaging or Message Authentication, Reporting, and Conformance. DMARC does not seek to reinvent what SPF and DKIM already accomplish, but rather builds upon these two standards. This included introducing a feedback loop for senders so as to provide visibility into how mail servers were handling email deliveries to recipients, along with providing domain name owners with a reliable means to explicitly provide direction on what should happen when SPF and DKIM validation fails for an email. DMARC also closes an additional security loophole related to spoofing attacks on the visible from address that recipients see when reading an email. So since SPF and DKIM are the foundation on which DMARC operates, let us very briefly revisit a few key points about SPF and DKIM from the prior episode in this webinar series as a quick refresher, and to add some clarification as it relates to DMARC. So as you may recall, Sender Policy Framework, or SPF for short, enables a domain or subdomain owner to list the specific public IP addresses that may send email for that domain or subdomain by using a DNS text record. Now, we also discussed the importance of using a hyphen all keyword at the end of your SPF record as a best practice. This is especially important when using SPF in combination with DMARC, as using any other variation of the all keyword, including the tilde all, will weaken the enforcement of your SPF and DMARC policies, creating an opening for an attacker to bypass. So domain keys identified mail enables a sender's mail server to create two digital signatures known as hashes. One hash represents the body of the email only, and the second hash is the body of the email plus select email header fields like to, from, date, and so on. These hashes make it possible for a recipient to confirm not only that your mail server actually sent a message, but also that the message was not tampered with in transit to the recipient. It is important to regularly do DKIM key pair rotations. DKIM key pairs are not intended to be set and forget. If a DKIM key pair is rarely or never rotated, you are granting an attacker an unlimited amount of time to obtain your DKIM private key. If your DKIM private key is compromised for any reason, any DMARC policy you create can easily be bypassed. If you are unsure of the time interval on which to rotate your DKIM key pairs, consider rotating them at least once per year, if not more frequently. Depending on your organization's risk tolerance, bear in mind that you should ideally keep the old DKIM public key published in your DNS text record for about 1 week after rotating your key pair. This allows sufficient time for any email that's still in your postfix deferred queue within Zimbra to be sent. So in the previous episode of this webinar series about SPF and DKIM, one of the participants brought up a good point related to deprecated email security standards. So years ago, Microsoft had refused to support the SPF standard, which is now in widespread use, and was instead advocating for senders to use their proprietary version of SPF called Sender ID. Ultimately, there was never really any widespread adoption for Sender ID, and Microsoft later dropped it and began supporting SPF. If your DNS zone has been around for a long time, it is possible you may still have one of these old Sender ID records set up. They're pretty easy to locate as they will always be a DNS text record and contain the text SPF 2.0. And similarly, before DKIM became a standard, Yahoo's domain key standard provided a means to create what are called domain key policy records. These were originally intended as a means for a sender to advertise to recipients that domain keys had been set up for sender's domain. A domain key policy record and a modern DKIM record have some similarities, but they can easily be identified as they will always contain the keywords like O equals hyphen or O equals tilde. Now, if you have either sender ID or domain key policy records in your DNS zone from the past, consider deleting them to make future email delivery troubleshooting easier and to avoid unexpected delivery outcomes. While neither of these should technically interfere with modern standards like SPF, DKIM, and DMARC, should your mail server send email to a server still honoring these historical deprecated standards, it might cause unexpected things to happen. So sender ID and domain key policy records should be removed. So next, let us take a look at how to set up DMARC by example. So meet Chris. He runs a technology company that hosts email for his clients, and Chris's company domain name is Zimbra.tech. His employees all send email from addresses that end in @Zimbra.tech. For example, Chris@Zimbra.tech. Now, Chris is new to DMARC, and soon wants to deploy it for all of his clients' domains, but first would like to get some experience with DMARC by setting it up for his company's own domain name. Chris has already created his SPF and DKIM records earlier for Zimbra.tech and confirmed that they appear to be working correctly. So to get started, Chris creates a new DNS text record with a hostname of _dmarc.zimbra.tech. Next, Chris enters b equals dmarc1, semicolon, to indicate that this is a DMARC record and that it is using version 1, the only version of DMARC supported on the internet. This keyword must always be listed first in your DMARC record, but all other keywords that we're going to talk about today can be listed in any order. So since Chris is getting started with DMARC, he sets his DMARC policy to p equals none. This effectively means that no DMARC policy is being enforced and that Chris only wants to test and monitor how his DMARC policy might affect his email to recipients. If he were to enforce it in the future, anytime you are creating a new DMARC record, you should always start with a policy of p equals none to avoid accidentally impacting the delivery of legitimate email messages while providing you an opportunity to confirm that everything is configured correctly in your SPF, DKIM, and DMARC records. The p equals keyword is always required in a DMARC record. Now, DMARC policy provides explicit directions to a recipient's mail server on what must occur if an email fails both the SPF and DKIM checks. For example, if a recipient's mail server received an email from an IP address not in Chris's SPF record, and the DKIM check failed because the message was tampered with before it reached the recipient, then the policy that Chris sets in his DMARC record would be applied by that recipient's mail server. You may find it odd that I said that both the SPF and DKIM checks must fail for the DMARC policy to be applied, as this can seem a little bit counterintuitive at first. This is in fact by design in the DMARC standard, as there are many common circumstances where only SPF or only DKIM passes, but not always both. And an email should still be delivered in those circumstances to the recipient, so long as either one or the other passes. Later in the webinar, I will show you an illustration of why this might occur. So as you can see on screen, there are two other DMARC policies options available to Chris, p equals quarantine and p equals reject. When set to quarantine, if an email fails both the SPF and DKIM check, again, the keyword being both, then it will be sent to a recipient's spam or junk folder. Or if the policy is set to reject, then the email will be deleted by the recipient's mail server. Again, if both SPF and DKIM checks fail. So there's another way that a DMARC policy would be applied by a recipient's mail server, even if SPF and DKIM both pass. You may recall from earlier in this webinar, I mentioned that one of the benefits offered by DMARC is that it prevents spoofing of your organization's domain name and the from address of an email. Later on, I will show you an example of how DMARC checks for spoofing of an email's from address, and if spoofing is detected, the policy that Chris sets in his DMARC record would also be applied by a recipient's mail server, again, even if the SPF and DKIM checks both pass. So next, Chris takes advantage of a reporting feature built into DMARC that will send summaries known as aggregate reports to a dedicated email address he set up for this purpose called dmarc@zimbra.tech. The RUA keyword means reporting URI for aggregate reports. This informs recipient mail servers that have recently received email from a Zimbra.tech email address that they should send an aggregate report to dmarc@zimbra.tech showing the results of email messages received from Chris's company, such as if they passed SPF, DKIM, or the DMARC checks. Now, not all recipient mail servers will send Chris reports, but at the minimum, the very largest email service providers typically do and will do so often about every 24 hours. The RUA equals keyword is optional in your DMARC record. The reports are going to be sent to Chris as an XML text file, typically within a zip or tar gzip email attachment. Now, depending on how much email Chris's company sends each day, he might receive anywhere from just a few of these to more than 100 per day. So it is always wise to set up a dedicated email address to receive these reports. Now, later in the webinar, we will look at an example of what these reports contain and how they can be used. In the previous episode of this webinar series about SPF and DKIM, I briefly introduced the same DMARC reporting capability, but solely for the purpose of collecting IP addresses that were sending email for your domain name, so as to assist you with creating a complete SPF record. In this webinar episode, I said that the email address, in that prior webinar episode, I said that the email address used with the RUA keyword must use the same domain name as the DMARC record's hostname, which in this example is Zimbra.tech. This was actually intentional to avoid a longer discussion at that time about how DMARC works. So now that we're talking about DMARC, I can get into that in more depth, and I can provide you with those additional details on how to send DMARC reports to any email address. So in this instance, Chris wants to send his DMARC reports to a different email address of reports@example.com. So for Chris's own DMARC record, it is a simple matter of changing the RUA keyword to mail_to:_reports@example.com. However, there is one more essential step that Chris must complete before these reports will be sent to this outside email address. Chris will need to create another DNS text record, but this time on the example.com domain with a hostname of zimbra.tech.report._DMARC.example.com with the content of v=dmarc1:. This provides the owner of the example.com domain with a means to grant permission to receive DMARC reports related to Zimbra.tech. So if this DNS record does not exist, then the reports@example.com address that Chris entered in his own DMARC record for Zimbra.tech would otherwise be ignored, so no reports would be received at that point. So returning back to our earlier example, Chris now adds the RUF keyword, which stands for Reporting URI for Forensic Reports, to his DMARC record, with an email address of dmarc@zimbra.tech. The RUF keyword is increasingly being ignored by the majority of mail servers due to privacy laws, but is mentioned here for thoroughness. And when used, it indicates that Chris would like to receive a copy of any email messages that do not pass both his SPF and DKIM policies, or that contain spoofing of the Zimbra.tech domain name in the emails from field. It is at the discretion of the recipient server if they wish to send a copy of the entire original message or just the email headers only. Use of the RUF keyword is optional in your DMARC record. So Chris's DMARC record not only provides a policy for his Zimbra.tech domain name, but it also automatically extends blanket coverage of the same DMARC policy to all of his subdomains too. For example, support.zimbra.tech or ftp.zimbra.tech, and so on. However, the DMARC standard allows for a few different options to precisely manage which DMARC policy is applied to the subdomains. One of the options is the SP keyword that stands for subdomain policy. Using the SP keyword, Chris can explicitly set a blanket DMARC policy that he wants to apply to all of his subdomains. If Chris does not include this SP keyword, then DMARC will automatically apply whatever policy is set in the P= keyword instead to all of his subdomains. So for most DMARC rollouts, it is best to specify the optional SP keyword, allowing for separate blanket DMARC policy to be applied to those subdomains. That can be different, of course, from the main policy of P=. This, of course, allows for a more controlled rollout of DMARC so that when the organization's domain name, Zimbra.tech, is ready to use a policy of quarantine or reject in the P= keyword, the subdomains can actually continue to temporarily use a DMARC policy of just none, providing Chris with more time to check those subdomains and make sure that everything's in order. And let's see here. Okay, and then to expand on how DMARC policy applies to subdomains, consider this example. Now, Chris's company has successfully secured their domain name, Zimbra.tech, with a DMARC policy of reject. And he has likewise applied a blanket policy of reject to all of his subdomains too. But there's a problem. A legacy app that Chris's company uses to send email from his subdomain, support.zimbra.tech, has no support at all for SPF or DKIM, thereby preventing him from using DMARC for that subdomain. Until his legacy app can be upgraded or replaced, Chris solves this problem by carving out an exception for the support.zimbra.tech subdomain by creating a new DNS text record for _DMARC.support.zimbra.tech and setting the p equals keyword to none. You will notice that within the _DMARC.support.zimbra.tech record, that Chris has set his SP equals keyword to reject. This is important as it makes it difficult for the bad guys to use a spoofed email address like spammer@kc.support.zimbra.tech. In other words, the SP equals keyword in this context is being used to explicitly state that this DMARC policy of none applies only to support.zimbra.tech and no other subdomains. So again, returning back to our earlier example, Chris now adds the FO equals 1 keyword to his DMARC record. Now this keyword is an acronym for failure option, and it enables Chris to request DMARC reports anytime a recipient receives an email allegedly from the Zimbra.tech domain or one of his subdomains, such as if they were to fail SPF or DKIM checks. Now this setting also means that if an email fails DMARC alignment, which is a concept I will explain shortly, a DMARC report will also be sent. But for now, let us presume that DMARC alignment failure refers to an email with a spoofed from address. It is generally a best practice to use the FO equals 1 setting, as this will give you visibility into any email that fails for any reason, including both legitimate email and email abuse from spammers and phishing attacks. In contrast, if Chris were to use the FO equals 0 setting, this would require every check to fail and will most likely result in DMARC reports containing only email abuse from spammers and phishing attacks. The FO equals 0 setting, along with the FO equals D and FO equals S settings, can make it difficult to find and correct potential problems with legitimate email deliveries too, so they are often best avoided. So let's change our focus from creating a DMARC record and talk about how DMARC goes about protecting your domain and subdomains. So when you send a message from your computer or your mobile device and it reaches your mail server, your email will be digitally signed by DKIM. And in the previous episode of this webinar series, I talked at length about how the signing process works. So we're going to skip over that process here for the benefit of time. But next, your mail server does the necessary DNS lookups to find the recipient's mail server on the internet, connects to it, and hands off the email for delivery. Again, none of these steps on this slide involve either SPF or DMARC. Now, once a recipient's mail server receives your email, a series of things are going to happen. This includes a test of your SPF record, if you have one configured, a test of your DKIM signature included in the email, again, if present, and a DNS lookup for your DMARC record, which if found, DMARC alignment tests will be performed. Again, I will elaborate on how DMARC alignment tests work here momentarily. Then, after steps 1 through 3 are complete, the recipient's mail server will check if either the SPF or DKIM test passed. Now be aware that DMARC does not require both SPF and DKIM to pass, but only one or the other. Ideally, we would like SPF and DKIM tests to both pass, but we will again look at a common use case later on that shows why this might happen. So as shown in step number 5 on the slide, if an email fails the SPF and DKIM tests, the recipient's mail server will take the action provided in your DMARC policy as specified by the P equals or the SP equals keywords, such as none, quarantine, or reject. What can be confusing for someone who's getting started with DMARC is that your DMARC policy might still be applied to an email that passes the SPF and DKIM tests, but yet fails what is called DMARC alignment. So let's break down exactly what DMARC alignment means. So DMARC Identifier alignment is the technical name for it, but I'm just going to call it DMARC alignment for short. Tends to be one of the least understood parts of the DMARC standard. One of the purposes of DMARC alignment is to ensure that the from address that a recipient sees when reading an email message actually matches the email sender's real domain or subdomain. In other words, this prevents the bad guys from sending spoofed emails that originate from badguy.crime and instead appear in a recipient's inbox using a spoofed domain name like yourbank.example. If DMARC had been set up for the yourbank.example domain with a policy of reject, then this type of spoofing attack can be stopped entirely, preventing the recipient from even seeing these types of messages, including avoiding a recipient's spam folder. So another purpose of DMARC alignment is to prevent the bad guys from registering a domain name, publishing their own SPF, DKIM, and DMARC records, so as to lend credibility to their email campaign, then sending those sending those emails with spoofed from addresses that email recipients see to make their spam or phishing email appear to be originating from your company's domain name instead. But again, if you have already published a DMARC record for your domain and you are using a DMARC policy of at least quarantine, if not reject, this will effectively stop this type of email abuse too. After you've deployed your DMARC record, you may encounter occasions where DMARC alignment unexpectedly fails, thereby causing your entire DMARC policy to be incorrectly applied to legitimate email. So it is important to have an operational understanding of how DMARC alignment is tested on a recipient's mail server to assist you with troubleshooting. So let's take a look at an example of how this works. So all of the DMARC alignment tests focus on the email headers within a message. If you would like to see a sample of what email headers look like in the Zimbra web client, just right-click on any email, then click on Show Original from the menu. For Outlook, you can do it by double-clicking on an email to open it in a new window, then click on the File tab, the Info tab, and the Properties button. Nearly all desktop email clients offer a similar feature. So on the left portion of the slide, I have selected just a few email headers typically found in most messages, and on the right, I have included the DMARC record for the Zimbra.tech domain. When a recipient's mail server begins testing for DMARC alignment, it begins with what is called an SPF alignment test. The SPF alignment test is concerned with just two fields, the return path and the from header, both highlighted on the slide. What the SPF alignment test is looking for is that the domain name used in the return path is the same as that found in the from header. Now we can see in this example that both fields use the same domain name, Zimbra.tech. So the SPF alignment test in this case would pass. The from header is what the email recipient actually sees when they are reading the email message. Now consider this example. The return path has a subdomain of mail.zimbra.tech, and the from header has the domain Zimbra.tech. While these are not an exact match, they still are using the same domain name Zimbra.tech. So again, the SPF alignment test would pass here successfully too. Now the SPF alignment test passes because by default, DMARC uses what is called relaxed mode. Now relaxed mode is what the majority of DMARC policies use. But if we wanted to require an exact match so that the domain and the return path must always match or always exactly match the from header, we could modify our DMARC policy by enabling strict mode with the ASPF equals S keyword that you see on the right. With this change to our DMARC policy, the SPF alignment test for the same email message would actually now fail rather than pass because mail.zimbra.tech is not an exact match for Zimbra.tech. And as a final example of how SPF alignment works, take a look at this sample, where the return path field is now empty, while the from header is still Zimbra.tech. There are occasions where the return path field might be empty, for example, when an out-of-office reply email is sent. In this case, the SPF alignment check will ignore the return path field, and instead, it looks at the from header in the email and the EHLO greeting it received from the sender's mail server when the message received. The EHLO, or Extended SMTP Hello command, is used anytime an email delivery occurs between two mail servers. It is essentially how the sending mail server identifies itself to the recipient's mail server. In this example, the SPF alignment test would successfully pass. And again, this is because the DMARC policy is using relaxed mode. And in relaxed mode, the Zimbra.tech domain is present both in the EHLO greeting from the sender's mail server along with the from header and the email message, so they match. So in addition to SPF the alignment test demonstrated, there's also a DKIM alignment test that takes place on the recipient's mail server. For this test, the D equals tag inside the DKIM signature is examined, as highlighted on the slide, along with the from header also highlighted on the slide. In this example, we can see that the DKIM signature domain is set to Zimbra.tech, and the from header also contains Zimbra.tech, so the DKIM alignment test successfully passes. Now, if either of these were using a subdomain of mail.zimbra.tech, while the other was using zimbra.tech, the DKIM test would again still pass successfully because our DMARC policy is using relaxed mode. So there's an equivalent for strict mode, but this time for DKIM. If we were to introduce the a DKIM equals s keyword to our DMARC policy, as you can see on the right, that would require strict mode, essentially requiring both domains to exactly match. And as you see in this example on screen, this DKIM alignment test would actually fail because they are not exact matches for one another. So now let's bring it all together and let's look at the big picture of how these individual parts of DMARC all work together. So in the upper right corner of the slide, we have a DMARC policy for our domain, zimbra.tech, and we can see that it's enforcing a policy of reject for both zimbra.tech along with all of its subdomains. The table you see on screen presents a number of different outcomes that can occur with this DMARC policy. To explain how to read this table, I'll pick out just a few examples to walk through. So let's start with row number 1. We can see that a recipient's mail server received an email that successfully passed the SPF test, and the email originated, meaning that the email originated from an IP address in the sender's SPF record. It also passed the DKIM test since the DKIM signature inside the email was valid. Next, the SPF alignment is tested, and the domain and the return path and the headers match. So finally, the DKIM alignment was tested, and the domain provided in the DKIM signature and the from header also matched. Since both SPF and DKIM alignment passed, this means that the overall DMARC alignment passed. So we can see that the DMARC policy applied was none, meaning that the email was delivered to the recipient's inbox. So now let's skip down to row number 5. So here we can see that the SPF test failed, in addition to the SPF alignment test, perhaps because the user had email forwarding enabled. But the DKIM and DKIM alignment tests passed. Now in this case, the overall DMARC alignment would still be considered to have passed, even though the SPF alignment test failed. Again, this is because DMARC only requires that either the SPF or DKIM test pass. Since DKIM was the only test that passed, and the corresponding DKIM alignment test also passed, then the DMARC policy applied is none. So again, the email is delivered successfully to the recipient's inbox. And to finish the slide, let's take a look at row number 6. In this case, both the SPF and DKIM tests passed, but also the SPF alignment and DKIM alignment tests failed. So since neither of the alignment tests passed, it means that the overall DMARC alignment also failed, and this message will be rejected, or that is deleted by the recipient's mail server. So while it is possible to only use SPF or only use DKIM in combination with DMARC, this table helps illustrate for you why it is important to use both SPF and DKIM with DMARC. Essentially, it allows you a fail-safe. So if one test fails, you have another test to still get your email through. By having both of these in place, it gives you basically the best possible chances of reaching the intended recipient's inbox. So I want to bring a couple of Zimbra settings to your attention that will kind of make or break DMARC alignment, just to make sure you're aware of them. So in the out-of-office replies feature in Zimbra, there is a global setting that you should check called Zimbra auto-submitted null return path. Now you want to consider setting this value to false if it is not already. If this value is set to true, it will cause the return path email address to be empty for any out-of-office reply sent. And this will create a problem for recipients receiving these emails due to the SPF alignment test failing when your DMARC policy is set to a policy of quarantine or reject. So newer versions of Zimbra should use a default of false for this setting, but older Zimbra versions might still be using a value of true. So again, this is something just to double check on to avoid problems with out-of-office replies. A second setting to be aware of in Zimbra that can cause email deliveries to fail when using DMARC relates to the Zimbra web client personas feature. If you have a mailbox called user@domain1.com set up with an alias of user@domain2.com, and you've created a persona in the Zimbra web client for user@domain2.com, anytime you send a message using this persona, Zimbra will set the return path email address to user@domain2.com, and the from header to user@domain1.com. So if your DMARC policy is set to quarantine or reject, this all but guarantees that you're going to have an SPF alignment test failure. Because again, the return path and the from header do not match. So there are valid circumstances where this might be desirable, especially if you wanted to hide the real email address, in this case, user@domain1.com, from a recipient. But if you start experiencing trouble with DMARC preventing delivery of these types of messages sent from personas, you can always change the Zimbra SMTP restrict envelope from setting to a value of false. This setting can be applied to just an individual mailbox user, an entire domain, or a class of service in Zimbra using the zmprov command shown at the bottom of the slide. So in the earlier example, Chris set up his DMARC record as you see on the slide. With this policy, Chris can expect to start receiving aggregate reports from recipient mail servers who have received an email from any Zimbra.tech email addresses recently. So these reports should typically arrive about every 24 hours, but there is nothing in the DMARC standard requiring this particular interval. It is actually solely at the discretion of the recipient's mail server of how frequently they wish to send these reports. Chris can attempt to override this 24-hour interval using the RI equals keyword in his DMARC record, where he can basically specify the number of seconds that should elapse between the reports. But this is not always honored in practical use by recipient mail servers. The reports will always be formatted as XML text files and are often sent as a zip or tar-gzip email attachment. Now, to examine these reports manually, you could use a free tool like 7-zip for opening the compressed files, and Notepad++ can be helpful for formatting the XML into a more readable format. So this is a sample of what a typical DMARC aggregate report looks like. In the first half of this report, we can see that the report was sent from Google, and they provided their contact information along with some other related fields like a unique report ID, a beginning and ending date range. Now the date range may look a little bit strange, but it's basically the number of seconds since epoch, which translated basically means the number of seconds since midnight, January 1st, 1970. Now, there are all sorts of tools online if you do a search for the keywords of epoch converter that will yield ways to easily convert those large numbers to an actual human readable date and timestamp should you need that. So next, we see in the policy published section, this simply shows the DMARC policy that Google retrieved for the Zimbra.tech domain. So the ADKIM and the ASPF tags indicate that Chris's DMARC policy is using a relaxed SPF and DKIM alignment testing, which we spoke about earlier, and this policy applies to 100% of Chris's email messages. So in this second half of the same DMARC aggregate report from Google, we now see the DMARC test results for 3 email messages that all originated from the IP address of 209.136.73.104. The policy evaluated section indicates that all 3 of these messages successfully passed both SPF alignment and the DKIM alignment tests. So a DMARC policy of none was applied, meaning the messages were delivered to the recipient's inboxes normally. Now recall from earlier that only SPF alignment or DKIM alignment must pass for overall DMARC alignment to pass. So in this report, it shows that the best case scenario actually occurred, where both the SPF and DKIM alignment tests passed. So in the Identifier section, this is the domain that was found in all 3 emails from field. That must pass either SPF alignment or DKIM alignment for DMARC alignment to pass. And finally, in the auth results section, this shows us that the DKIM and SPF test passed. This is not to be confused with DKIM or SPF alignment, but rather just a regular SPF test and a regular DKIM test. So it almost immediately becomes infeasible to read DMARC reports individually, as you will likely receive many of these per day. So the previous slides were simply an illustration to show you what is actually in those reports. But in real-world use, you're going to want to use a reporting tool. And there are a number of commercial options which can basically help you parse the contents of those reports and then automatically put it into a format that is much easier to read. There's also various open source options available that are free. Just be careful if you choose the commercial option, because for many of these vendors, it becomes quite expensive to manage more than 1 or 2 domains at a time. And that could be where the open source options start to become more attractive. So as you can see on the URL there on the open source options, just simply searching for the keyword of DMARC and GitHub will render you many, many different options from which to choose. So let's wrap up our discussion of DMARC by reviewing some best practices. Before getting started with DMARC, you must deploy either SPF, DKIM, or preferably both. Recall from the earlier slides that having both SPF and DKIM available gives email from your domain the best possible chances of successfully passing the DMARC checks. However, there may be situations where an email sending server can only support SPF or DKIM, but not both. This is still okay, as you can still use DMARC even with those servers too. Next, set your DMARC policy for your organization's domain to p = none and sp = none, along with the RUA keyword to start receiving DMARC reports. For each DMARC report that you receive, use a DMARC reporting tool, such as one of those provided on the prior slide, to check for IP addresses that are authorized to send email for your domain name, but that are not already in your SPF record. If you find any, correct your SPF record as needed to ensure it is complete and accurate. Now next, you'll want to check your DMARC reports for any DKIM validation failures. The DMARC reports will always include the DKIM selector name that was being evaluated, so you can easily identify which email server originally sent the message. Check any of the affected server's DKIM configurations to ensure they are correct should you run into this problem. And finally, also in the DMARC reports, look at any SPF alignment or DKIM alignment test failures. These will give you an early warning if your email servers are sending either the return path or setting your return path or from header fields incorrectly. As shown in the prior slide with the Zimbra settings you may need to adjust, many times these alignment errors are relatively easy to fix. Now keep in mind that you must publish only one DMARC record for a given domain name or a subdomain. In large DNS zones, multiple conflicting DMARC records often tend to occur by accident. If you are publishing multiple DMARC records for a single domain or subdomain, it will lead to pretty unpredictable email delivery results because you will simply not know which DMARC record a particular recipient is using. So your goal with DMARC is to reach an enforcing policy of P = reject and SP = reject. Many organizations initially deploy DMARC in monitoring mode, which is great, but they fail to complete the transition into an actual enforcing policy, again, a quarantine or reject. This is unfortunate because the organizations are effectively negating the benefits of using DMARC, leaving their domains and subdomains open to abuse and reputation damage. Also, avoid the temptation to skip from a policy of none directly to reject. When introducing a DMARC policy, it is very important to transition from none to quarantine to reject, as the middle step of quarantine provides an opportunity to check for any incorrect configuration errors before moving to the more strict reject enforcement level. Smaller email sending domains might be able to make this progression more quickly, possibly in a matter of days, while larger email sending domains may require months to reach the reject level. Now, any of your non-email sending domains or subdomains are subject to abuse just by the fact of their existence. For these non-sending domains, consider setting the SPF and DMARC policy shown on the slide to prevent recipient mail servers from accepting email from any of these domains. It can be of value to monitor attempts to send email using these domains, so you might want to also consider adding the RUA = keyword to the DMARC policy to receive reports too. Once you reach a DMARC policy of reject, your DMARC record is likely to remain pretty stable and rarely in need of an update. However, DMARC is not set and forget. Keep a lookout for a noteworthy increase in the volume of email failing SPF alignment or DKIM alignment tests. This can indicate abuse or a reconfiguration of your records that may be needed. It's typically SPF records are the ones that need the most ongoing attention. Also, look for any new unexpected subdomains that are sending email. This can be indicative of abuse or third parties with a legitimate need to send email using a subdomain, perhaps again, that need to be added to your SPF record. And finally, look for any unexpected IP addresses sending email on behalf of your domain. Well, this could be a sign of abuse. It again can also be indicative of a third party that is legitimately sending email on behalf of your domain, again, requiring your SPF record to be updated. So you may have some third-party vendors that send email on your behalf that always fail DMARC alignment when a policy of quarantine or reject is being enforced. Now, your best shot is to try to work with these vendors to solve this problem. But there are going to be cases where this is just simply impractical. It may be a situation where the vendor does not support these standards and has no intention to do so in the future. And if that is basically the case, then your only other choice is to isolate the vendor on a subdomain of their own with a DMARC policy of P equals none and SP equals reject. What this does is it enables you to still enforce proper DMARC policy for your domain and other subdomains while basically carving out an exception just for that one vendor using that particular subdomain. But you should still keep pressure on that vendor to fix the underlying cause of the DMARC alignment failure, especially when their contract is coming up for renewal. So I'm going to pause here and see if you have any questions to answer related to DMARC.
We have one question. I think I know the answer, but I'm not 100% sure. So that's Noah. He's asking, how do we safely allow AHLO with a different domain for a shared hosting mail server? And I was thinking that as long as you don't have a null return pad, so you have a proper return pad, then the EHLO doesn't matter, right?
That's correct. So Noah, in that case, your very best bet in a multi-tenant environment like you're describing is to make sure that that return path is always being set. Again, the EHLO greeting from the sending mail server is going to essentially be ignored as long as that return path is always there. So again, you may remember from the prior slide where I was talking about changing that particular Zimbra setting that affects out-of-office replies. That would be an example of one of the settings to watch out for.
Yeah, and then the other thing that I advise is I think you can always put a CNAME on your client's domain and then for the DKIM keys, and doing the DKIM signing on your own system, so on the systems that you manage, and that would also make it that DMARC passes, right?
It can, yeah, that can actually be a very effective strategy. What I have typically seen with clients, again, in a multi-tenant environment, is the client may be managing their own DNS records, maybe at a cloud provider, maybe in their own server farm, whatever it may be, and their DNS server does not allow, for example, very long DNS records, typical of what you would see with a DKIM key. So you can use Barry's CNAME approach to host those DKIM records on your own DNS server that is able to handle those long records, and then simply have the client put in a CNAME record on their DNS server pointing back to you.
Yeah, thanks. Thank you very much. I think that answers the question, and you worded it very well.
Okay.
I don't have any other questions right now.
Okay, great. All right, so to wrap things up, here are some key takeaways to keep in mind. So remember to start slowly with rolling out DMARC with a policy of none, followed by quarantine, then reject. Avoid the temptation to skip from none to reject, even if everything seems like it's working fine. It will always surprise you when you first go to enforcement mode. And again, that is the benefit of the quarantine setting or policy to give you that extra leeway to fix problems before they become serious. It is far better to send a message to somebody's spam folder than to simply have the recipient delete it outright, as would happen with the reject policy. Second, set up an open source or commercial tool early on to help you parse and summarize the DMARC aggregate reports. Those reports are going to offer critical information on how recipients are handling your email, but again, be under no illusion that you can manually read those reports on a daily basis. It simply is not practical for most email sending domains. And then next, do not overlook protecting your non-sending domains or subdomains with a proper SPF and DMARC policy. Doing so is like installing locks on your doors, but failing to use them. That is in effect what it is like if you do not protect those non-sending email domains. And the next, also take the time to understand how DMARC alignment works. I know that it's a complicated topic, and it again is one of the most misunderstood parts of DMARC, but it really pays off when you're trying to do troubleshooting of why a message did not pass DMARC, because 9 times out of 10, it tends to be a DMARC alignment problem. And next, do not allow vendors who cannot support SPF, DKIM, and DMARC to hold you back on securing your domain and subdomains with DMARC. I've run into many companies out there that think that simply because some vendor that they work with or some software app that they're using cannot support one of these standards means that they can't use DMARC at all on their domain. And that is simply not true. Instead, use the strategy I discussed on the earlier slide and put those non-compliant vendors or software apps on their own subdomain, again with a policy of none, DMARC policy of none. And if they still continue to refuse to improve, then simply plan on seeking out a vendor alternative. So again, thank you so much for attending today's webinar. I hope you found it educational, and I am going to leave you with just a few links that you can use for testing your DMARC records. If you would like to reach out to me directly with additional questions or feedback, my contact information is included.
Thank you all very much for your attendance. Thank you, Randy, for doing this marvelous presentation. And I hope to see you all again on the next webinar, which is somewhere next month. Thank you all. Bye-bye.
Thank you.